This recording is for those who want to complete the Unit 5 sample work. Unit 5 sample work is vocabulary for the area lesson, area unit. I'm going to start by going through the lessons. So I'm on Unit 5, Lesson 1. On the second slide, it lists several key words here. So let's go ahead and define them. And it lists some parts of parallelograms and triangles. Okay, so altitude of a parallelogram. Okay, it's the perpendicular height. Example, I'm going to draw a parallelogram and refer to it repeatedly. So I'm going to use one single example for multiple words. Okay, here we go. So a parallelogram is a quadrilateral with two sets of parallel sides. Okay, and the altitude of the parallelogram is the perpendicular height. So it is perpendicular to the side that we call the base. So this is the altitude. Okay. Altitude of a parallelogram. Base of a parallelogram. Parallelogram. The side perpendicular to the altitude. Because actually, if we turn this parallelogram up on its side, we could make any side the base. Particularly, it's the one that is perpendicular to the altitude. So that's the base. Note that it would be logical to call this the base as well. So the base is, there are two bases that way. All right. And height of a parallelogram. Height is just another word for altitude. The altitude. Example, this is also the height. Okay, next words have to do with triangle. So we have base of a triangle. The bottom side. Note, by the way, and again, I'm going to draw one triangle as my example for several words. Note that any side technically could be the base if you rotate the triangle so that the side is on the bottom. Okay. But it's kind of what we consider to be the bottom. This is the base. It's all about the base, no trouble. Okay. All right, base of a parallelogram, or base of a triangle. Height of a triangle. height of a triangle. Perpendicular to the base through the opposite vertex. Okay, so it goes through the opposite corner. It's also called the altitude of a triangle here. This is the height. Okay. Height of a triangle. I believe that is it. Base of a triangle, height of a triangle. Okay. So I'm going to lesson number 2. Areas of trapezoids, rhombuses, and kites. Okay. Height of a trapezoid. It's the next word. The height is measured perpendicular to the bases. You may recall that in a trapezoid, there are 2 parallel sides. Those are called the bases of the trapezoid. The height is measured perpendicular to the base. Perpendicular, height. And I'll go ahead and add the word base there. Oh, they don't ask you to define the base. Okay, that's it from lesson 2. Unit 5, lesson 3. Apothem and radius of a regular polygon. Apothem. Okay, it's a segment. All of these are segments. From the center to a midpoint. Okay. For my example, I'm going to draw a regular hexagon. And it's easiest to construct a hexagon starting with a circle. If you measure off equal radiuses all the way around a circle, you'll make a hexagon, a regular hexagon. So here we go. Boom, boom. All right, there we go. And there we go. Good. And the radius is drawn from the center, or not the radius, the apothem is drawn from the center to the midpoint of one of the sides. Apothem. Okay. And then radius. Radius in particular of a regular polygon. Radius. It's kind of like the radius of a circle. It's a segment from the center of the polygon to a vertex. So a radius is drawn from the center to a corner to a vertex. Radius. And the radius is always longer than the apothem. Just like the hypotenuse of a right triangle is always the longest side. Okay, lesson 3, now lesson 4. Perimeters and areas of similar figures. There are no new words, so no vocabulary for you in lesson 4. Lesson 5, trigonometry and area. No new words for lesson 5. Lesson 6, circles and arcs. We've got quite a bit here on the circle front, so I'm going to start a new slide. Okay, and we're going to do a lot of these on the same circle here. So I'm going to start by defining the word circle. The official definition is all points in a plane, that makes it a circle and not a sphere, equidistant, I mean it's the same distance, from one point. Okay, so we've got a point right here. All points equidistant from that point. Note that the center of the circle is not part of the circle, but the circle is all points equidistant from the center. So this is a circle. Okay. And center. The center of the circle. Point from which all points are equidistant. Center. Okay. Diameter. And I'm not going in the order they're listed here. I'm trying to keep it logical. Diameter. Okay, and actually before diameter, it would make better sense to do a chord. We have chord on there. No, they don't have chord. That's surprising. Okay, I guess we won't do chord. Diameter. A segment connecting 2 points on a circle through the center. Okay, so it's got to go through the center. That's a diameter. I was going to say it's a chord drawn through the center, but chord's not one of our words, so we won't take the time to define it yet. Diameter. Okay, radius. Segment from the circle center to a point on the circle. radius. So from the center to any point on the circle is a radius. And all radii are congruent. They're all the same length. Because we define the circle as all points equidistant from one point. Radius. Okay, we've done diameter, we've done, okay. Circumference. Distance around a circle. Okay, so if the radius is 5 inches, then the circumference of this circle is 2 times pi times 5, or 10 pi. 2 pi r is the circumference. Distance around, 10 pi, which is approximately 3.14 times 10, or 31.4 inches. Okay. All right, so circumference, central angle. An angle with vertex at the circle's center. So this would be a central angle. Let's do it this way here. Central angle. Okay. Central angle. Okay. Got concentric circles. I'm trying to see what we haven't done. Congruent arcs, congruent circles. Okay. Now let's do minor arc and major arc. An arc measuring less than 180 degrees. Okay, if I label these A and B, then arc AB is a minor arc. Okay, major arc. An arc measuring between 0 and 180 degrees. Oh, no, sorry, not 0. Between 180 degrees and 360 degrees. Okay, so let's call this point D. Then arc BDA is a major arc. And note that you have to have 3 letters to name a major arc, because we have to specify go the long way around. Go the long way around the circle for a major arc. Okay. And we've got semicircle, which is related to these two. An arc measuring 180 degrees, exactly. Okay. Let's call this E. And arc ED is a semicircle. Now we want to be specific, so I'm going to say arc EAD. EAD. Because if I go through E, A, and D, that's a half circle or a semicircle, 180 degrees. Okay, now let's go through and catch the ones that I missed. Concentric circles. Circles with the same center. Think the Target logo or a bullseye. Same center. Two circles, same center, concentric. Con together, centric, same center. Okay. Congruent arcs. Arcs with the same measure. Okay. Let's say arc BA is 60 degrees. And let's say arc ER is 60 degrees. Then arc EAB is congruent to arc ER because they have the same measure. Okay, congruent arcs. Congruent circles. Okay, we're running out of room, so we're going to have to move things up here a little bit. Congruent circles. Boy, this lesson has a lot. Circles with the same radius. Any circle with the same radius is congruent. So I'm going to draw a pair of circles, different centers, but same radius. And they will be congruent circles. Okay? Congruent circles. Congruent arcs we did, congruent circles we did. Pi. It's a Greek letter with this symbol. It has two legs. Technically, you're supposed to curl the one there and curl the top like that. But most people just do two lines and a line on top. Okay? And it is the ratio, in mathematics, it's the ratio between circumference and diameter. Okay, so let's say this has a radius or a diameter of 1, 2, 3. Okay, then its circumference divided by its diameter is pi. Or another way to say that is circumference is 3 pi. Okay. Pi, radius, and semicircle. Okay, we got them all. All right, so that's lesson 6. Lesson 7, areas of circles and sectors. This is the last lesson. It's got 2 words. Sector of a circle. Okay, I'm just going to define it as a pizza pie slice. Okay, that's a sector. So I'm going to draw a circle. Okay, and I'm going to draw two radiuses. One and two, and the two radiuses divide this actually into two sectors, but we're going to call this one a sector. We usually refer to the smaller of the two. Okay, and segment of a circle. A piece of a circle cut off by a straight line. So if I draw any old straight line through a circle, the segment of the circle is right here. Segment of a circle. All right, that is it. That is it. Let me make sure here. Lesson 7. Lesson 8 is co-portfolio. Lesson 9 is the review. Yep.